back, and welcome to those that are new. Glad to say we have the second one on. Yeah. Like we have a little bit of going on right now, I think. That's all it is. Yeah, okay. Just making sure we're not missing anything. We got about a 10-second latency, but that's cool. Today we're going to continue on with our modeling of the bicycle we did last week, right here. We have I've done, if you saw the video on the opening, we have a 3D printed it. See it here. Turned out pretty well. This is 55% of actual size. Turned out very well. The welds don't export. The welds that we put in, like welds up inside of here, that we put on around, they do not export STL, so it doesn't show that. If we wanted that in the show up in the print, of course we'd have to actually or fake them in with what's the word I'm looking for, with fillets or something like that. Make this all one body. I did export it all as the separate weldment bodies, and it came out very well. There was, since we didn't use gaps, it's in here, everything's nice and clean, but we can see that all the way through, exactly as we wanted it welded, and so on as we designed it. We're going to be building the handlebars, and the forks today, and the handlebars may be final design, but and we'll see how it looks when we start getting the rest of the bike together. But the forks, I think, are a preliminary design that we'll be adding on to, and I believe that it will be, when we get into it more, I think this part of our frame, our neck area, will be changing, getting larger or thicker. We'll be having areas for bearings and the gooseneck and things like that as we get to it. So it's not, we're not just seeing a part on one particular day, but we will be continually doing the design of. Is this going to be a complete design of a bicycle? No, we're not going to be putting in every intricate little piece of bearing like that. We may be going to McMaster and things like that, and build what we're looking for. Go to McMaster and, you know, getting some parts, bringing them into our assembly as we start building it and things like that. But we're still in the building of some of the parts before we really start assembling. By the end of today, we'll at least slide the forks in. That's about all. They'll just spin in there. There won't be anything holding nut, anything like that. We do a little more research on it, on how things go together on a bike. So I've taken my bike apart a million times when I was younger, but I wasn't looking at the design of it, that particular change or do whatever I'm doing. I also, as an improvement from last week, we now have Zoom. I know I was going like this. I was looking back at the video, looking for improvements that can be done, and I figured that something like, if I'm working up, call it in here, and I zoom in with Windows, this should be better for you guys to see. Come back and throw it back to regular Windows Zoom. So hopefully that will help today and make things a lot easier for us. So how many people we got here? We got 4 here, not too bad. It's only second week. Who do we have in there? I see Dave's out there. I see Maiden Mom's out there. Who else we got out there? Give a hey-ho or a hi up there in chat for me. You know who's out there listening and who's the bot sitting out there. Whatever the bots do on channels. We'll get more trickled in here as we go. Um, so today I'm gonna minimize the frame, and we'll get into modeling and what we're gonna be doing. So what we have here is the handlebars. What I planned for today is we're gonna draw the handlebars as I originally set them up for this particular what we're looking for stream, but and this will deal with 3D sketches and things like that. And hey, Mindy. And then what we'll do is do some design changes to it. I do not like how the front is here. Works. This pops out for the middle piece. I've never seen handlebars. Generally, they'll lay down nice and flat with this surface and this. So we'll change that, and we will also. That's the main change, and we get to do a few cool techniques, change a couple dimensions, things like that, to get it in place. The 1.161 dimension on here does not need to be like that. We are just basically drawing them in the kind of angled area that they will be on. In real design, I wouldn't put that there, but just in case that comment comes up. And so we'll go from here. This is going to be a big 3D sketch. Not big, but pretty decent. If you watch in chat, eventually Nightbot will tell you how, give you a link to how to do all 3D sketches, ins and outs, from my YouTube channel, and about 108,000 views to it. It's a pretty good tutorial, if I don't say so myself, but many other people have told me it helped them to stop pulling their hair out. And it gives the whole overview of 3D sketch and the ins and outs. The one difference is you'll see in the dimensions here today, as we saw last week in the 3D sketches, on how we can control them a little better than right. So let's start off. Let's get going in here. Nobody wants to see a blank screen. Okay, so take a look at our parts. We'll get a part open. And we're going to go right into a 3D sketch. Let's take a look at what we're going to be drawing first. Let's go back to the this guy here. And zooming on in. There he is. And so from the front it looks great, but from the side you can see it pops back. It's also popping out, which is for X, Y, and Z. And we're actually coming out, of course, in the X and the Y here, but also Z coming up. So what we're going to be doing is we're going to draw in half, and we'll be able to mirror this, unlike last week's debacle that wouldn't mirror on the frame. And deal with it. We're also going to use the actual weldment tool today. Yes, you could do a regular sketch, but I'm going to show the benefits of something like this, tubing, piping, things like that. This you might not think of as a weldment, which it actually is, but two different material sizes, they need to be cut together. And how long of a piece of material, how long of a piece of tube do you need for this outside piece? You could either start doing the math and giving it to manufacturing, or they do it themselves, or whatever. Or you could say, hey, here's what you need. So here, add an inch or two to it, and then you can cut it off at the end. And be more proactive on purchasing. So we'll come in here, and so we're going to start a 3D sketch. Start a 3D sketch. I prefer to draw my 3D sketches in isometric view as opposed to front and right and top, but I will switch that every once in a while drawing. We're going to use the regular everyday line tool, and I'm going to come out and get my about shape and do that second line. We got it here. Remember, the tab key changes which plane or piece of paper you're drawing on by default. So you know in space I draw it here, it's drawing it back. Hit tab again. We look like we're drawing up here, but we're actually drawing basically planar to the original line. But we want to go up. So I'm going to go up here. Start my next line. There's my I can tab around again. And I'm going to come back a little bit. Come up. So as we look around this thing, it looks nothing like what we're looking at. But now if I look at, say, right view, I can pull it back. Guy back a little farther. Look like. Look at him from the side here. We see it comes out. And we know he's going back. Pull him here. See, getting that look. If you just take a 3D sketch and break it down into little pieces, don't try to draw the world like you might do in a regular 2D sketch, which you shouldn't be doing anyway, in most cases. You break it down in a couple things and get them locked down where you start going farther and farther and farther in. For instance, with this one here, look down here, bottom here, we have we're going back 161 and going up 4. Welcome, Steven. Welcome. Happy you're here. Thanks for the follow. I appreciate it a lot. You'll be notified when you get in here. Yeah, Steven, I'm sorry. The lag just started. Of course, you go live and then lag happens. So it will be live. Get it later, but of course we can. What I'm looking for. We can still participate in here. Have a bit of a lag. Sorry. But with our dimensions here, we will. Let's see if I can fix something on the lag. At here. IT here for a second. All right, if that'll help in the lag. All right, back to our dimensions. We had that 1 inch 161 from here to here, and then from here to here this way, 4.25 approximately. So when dimensioning in the 3D sketch, I definitely can pick the line and the point, but this gives us this dimension here. Got it from the side. You can see it's aligned. It's the total length of that. That's not what we're looking for. And as we talked about last week, if I press the tab key, it won't update the drawing at all. But if I escape out and start over again and I go from point to point, now it's given me, of course, the length of that again, but I haven't clicked down. And you press the tab key and now I can get that distance. I can press the tab key again. I can get the total distance. You can see that it's a projection up there. Right in there. So we'll throw in this one first, which was our 1.161. And go from here to here again and tab to where we get our height, which was our 4.24. It brings them up. Always be checking your 3D sketches when you do it after you put some stuff in. Make sure you're still on the correct sides. You're not shot out in space somewhere. Things like that really can get in your eyes or get in your head. We'll deal with this one here because we can see it will still move, or it should move. Yeah, it'll still move. I can't go up or down, but it doesn't know where it needs to sit in space. We'll get these dimensions in and then we'll mirror it over and not have to deal with the rest of it. So we'll put in the last dimensions here. Same things here from here to here. Total height, a tab to get our height. And we will go 0.772. Our height, and you can see, as I mentioned before, not quite looking exactly like we want, but just like anything else, we can drag it around and get it a little bit better into what we were really looking for. Okay. Which is, we are all over the place. Let's get back into ISO. So, you know, my hotkeys, I have a hotkey to bring up the dimension command. Use the W key because it's right there by the escape and the space bar. W has nothing to do with dimensions, but I've always W because it's right there next to my middle, sitting on the left side of my keyboard because I'm right-handed. And Control 7 for everybody. It's easy enough. It's just enough for my hand. Control 7 will go into ISO. Control 1 goes into front. I'll usually go into front, hold down Shift, and use the arrow key, which will, the arrow key with the Shift goes 90 time. So when I'm flying around, that's what's happening. I don't have anything special set up other than the letter W for dimensions. Everything else, Control 1 through 7 are all of your views. And 8 is normal too, Control 8. All right, so here to here, get through to get our distance is 4.075 as the drawing says. So we're not fully defined yet because we haven't defined how far this point and this point and this point are from the middle or overall. When we take a look at our drawing, I prefer overall dimensions, and as we discussed in length yesterday, discussed in length last week, that I bring in my dimensions to my drawing. I insert model items, which we're going to be doing on this. This is a 3D sketch. This has got some weird dimensioning pieces that would be very difficult to get. We can actually dimension this up on our drawing when we get to it, like in seconds. All right, so and then we clean it up, make it look clean over the next 2 minutes, and we're pretty much. So what we're going to do is we're going to use the everyday 2D mirror sketch, but we are in a 3D sketch, new to, I believe, 18. I'm going to just have it in here. That there was a choose chain or select chain. And then mirror about, I'm going to use the plane 3. Right. Our preview up in there, and give it an OK. Welcome, Tim. I see you in chat. Thank you for coming again. All right. So from this point, we have our 3D sketch. It's all around. We have one single line at the bottom. We're not doing half of our 3D model and then mirroring it over. There's sometimes no problem with that, but if my point is to have an overall dimension on my drawing, I can't do that, especially in a 3D sketch. I can somewhat fake it in a 2D sketch, but not in a 3D sketch. Right, so I'll throw in the dimensions from the drawing. And if it looks like I'm looking up into the sky on video, I kind of am. I've got a 55-inch monitor here. I look up, there's a lot to it. Not sitting directly on the desk, so the other 3 monitors I have to do all this. 2 for visible on the stream and 2 for making sure the stream. So, but we can see here, we get a fully defined sketch now. In 3D sketch, I see a lot of 3D sketches that are underdefined, and underdefined in the design, in my opinion, not a finished. How does manufacturing get? You don't even know. Okay, so this is going to be, we're going to be using the weldment tools today. I'm going to do it both ways. I'm going to do it like last week, sweep, but then we'll do it. So that we actually have a length. What does manufacturing need to approximately get in length for manufacturing this for all the bends? You could waste a lot of stuff, or even in testing, but when you know pretty much really close how much you need in millimeters. So we're going to put on our 3D, I'm sorry, just a regular fillet tool. You're going to be sweeping this when you their sketch. Serious. Been on this time. I think I just threw in these. You guys have seen the the drawing for long enough. You probably have all the dimensions memorized. Come in here, and we're just gonna throw in our fillet sizes, corners. So 2.953 right here and right here. Give it an OK. Fillet up in this corner is 1.772. So here. Explaining that it'll break the midpoint relationship here, but once I put on both sides, it'll reattach it. There. You're welcome, Dave. Thanks for always telling me, man. Took me long enough. But I'll get better. Either you'll watch it longer or... All right. So we're going to do two things with this guy. I'm going to show you just the regular sweep for those that could care less about the weldment tools. And then I'll take that out and we'll the actual weldment structure or a structural member. Okay, so for those that don't care, this is a round profile as of about 17 or 18. SolidWorks 17 or 18. We don't need to create a plane perpendicular to the end, draw our circle, and sweep it through and use our pierce point like that. Nowadays, sweep, we just choose that we're going to put a circular profile. Great for any wire, any tubing, a lot of stuff that we do in sweep. So I say, well, here's my profile. I'm just going to sweep it through here. We get a preview of whatever number for size profile we're going to use. A drawing that you guys had to look at enough. It says 984. It'll pop out here in a second once the tab comes out. And that's a nice update there. It's nothing. Okay, there we go. And then a thin feature. We're going to use the 1.5 wall thickness that we've been using. 1.5 inches, 1.5 millimeters, and we want to keep that outside, so we're going to bring it to the. So we'll create our hollow piece. Yes, we could shell it out. Yes, we could have created a plane at the end, drawn two circles. Yes, we could have done a sweep that was solid and then a sweep that cut. All those options. On what your plan is. Your plan is to always use a particular tube. From there, we'll get there. See here, now that we extrude it, or sweep it, I'm sorry, we get our particular geometry. Now again, the problem with this is we without doing the math, we can't figure out how long this is for manufacturing, and that may not be a concern to you, and you can say through manufacturing I don't care, but some of us need to do that job or just want to give that job for our drawing. If we look down at the drawing again, you'll see, let me get out of this particular drawing, our next drawing, we can see here there's no cut list. It's just make this, do it however you need it done. But in the next one, we're going to be adding knurl too. But you can see we have an actual cut list that tells that we need. So doing it with a sweep, we don't get that capability without just making the table and doing those numbers in there. But doing them, putting the numbers in, as soon as you change that design, the numbers are different. So then you gotta go back in. But there's ways that we can take the original sketch get the number of the total length of the path in there, make it into a what I'm looking for. Make it into a variable, call that variable out. But why do that if SolidWorks going to do it all for you? Okay. And look at that, I switched back to the correct screen right after I was done with it. Getting better, guys. So I'm going to delete that out, and we're going to use the actual weldment tools today. It's curved, it's beyond something great, so it's different than for the standard use of weldments, but we definitely have it for the problem. And then go from there. So I'm going to use the weldments tab. If you don't have the tabs on because you don't use it, but you see that this may be helpful for you, you can always right click, and under tabs you can turn on whatever tabs you want for your command manager. Put them in alphabetical order, but they're there. You can turn them off, or right click and turn them on. So have them on and off. Of course, it's different for parts, drawings, and assembly. So we'll come in here and we'll use the weldment tools this time. So weldment. Last week we just hit weldments themselves for to make things not merge time for the bicycle frame. This week we're going to get this and build at the same time by just saying I want a structural member. It makes it a weldment when we're done, and then offers us what we want of what we want for profile. We don't have the exact profiles. I haven't built these profiles in here. There are literally probably close to 5,000 to 10,000 profiles that are available with your SolidWorks install. We may get into that on another particular one if people want to know more about the weldment. Or you can Google it for SolidWorks weldment profiles. There are so many different ones that are already without having to make your own, but you can also make your own. We're going to use the 21 by 0.3 by 2.3 millimeter ISO standard. It comes close to what we want, and then I'll show you how we can update it, and then it also will update the cut list for us. So we got groups. It's going to ask us for here. We are going to only have one group on this particular one. We're just going to pick through all of it. One thing I want to point out, again, as I pointed out last week, we can see that it's drawn the round profile, and it started here at this end. It really doesn't start, I mean, it doesn't matter where it starts, like in a sweep or something, but it starts there because that line that I selected, it starts at the beginning or the first point of that line, and it through from here to here to here. That was the particular line. We'll go through, and I'll continue to pick through, going in and taking that profile. So we're essentially getting a sweep in this particular case, but picking where we want it to go to. And looking through our options here, and it says merge arc segment bodies. If our particular purpose of this was to make all separate pieces, and our customer was going to be having maybe some plug that goes in there, or connectors that go in it, or going to add threads and screw them on, we could uncheck this, and it would make the 1, 2, 3, 4, 5, 6, 7, 9 separate pieces. So 7 pieces is not what we want here, so we want to make sure that the merge arc segment bodies is on, and I believe that automatically checks when it starts seeing that you're picking something like this in 3D space. It automatically checks it. I see right. Also, the little thing on the profile for those that don't use weldments very often or at all, under locate profile, way at the bottom behind here, but there's a little button called locate profile. It shows the actual sketch, and it allows us to pick any of these points, any point that is on the sketch, to be what follows the particular through. Usually it's the center for a circular piece, but if you have a square piece or rectangular piece of extrusion piece. You may want it. You may have drawn it based on the tabletop or a weldment, something like that. We're gonna keep it right there in the middle, and when I hit OK, we are going to get handlebars. Hide the sketch for now, and we can see this guy here. All right, so come in here, and we got some things to do. Well, first thing I want to do is show you that we can just update that weldment structure profile on the fly anytime we want. And then we also need to the center, do it based on the self that we had shown earlier. So we'll come in here and see it created the pipe. It tells us what pipe we may used or profile based on how we named it when it was created, or SolidWorks in particular case, SolidWorks Corporate or programmers. But we have the sketches in there, the plane that it created automatically that we didn't need to, because it is essentially a sweep in this case, and the information for that particular one. We do multiple profiles or multiple pieces. Say we did the center piece, center notch in the middle, and it was different, or I mean, it was the same size. We would have a different group in all the groups. But if I take a look at this sketch, I can either edit it, but I'm just going to double click it and look at its dimension. We have our inside and outside. So I'm going to double click on this guy. And we have a 0.984 diameter that we're dealing with. So rebuild it. We'll see it gets bigger. We'll see that it's going to be thick because the inside is still 684, I think it said. So come in here. Now I can either do the math. I want that 1.5 millimeter, and it is the ID that it's giving.
Everyone. This is the woodworking gamer over at Munchkin Metropolis.
You can go either
in our series of puzzle boxes for the month of April, and this box is my centrifugal force puzzle box. It's a really neat concept, and I love the mechanic. So let me show you a bit about this box. There don't appear to be many moving parts. There is this tab that lets you know the top does move. So that's obviously
always when you're.
There's also this little section here that kind of looks like it's glued in, so that maybe it would trick you to thinking that it slides, but it doesn't. And that's really it. If you listen inside, you can hear the pins clicking back and forth. Now to open this box, it's really simple if you know how, and almost impossible if you don't.
And on 3D,
inside there are 7 pins that alternate back and forth. And the pins inside that are alternating, as some disengage, the others engage. So the trick is to find a way to make all of the pins disengage at once. To do that, you simply spin the box to raise the top. Here, I'll show you that it's nice and locked.
guys, it's time.
And then I'll spin. That got most of the pins, but not all of them, you can see. So I'll spin it again. And bam, just like that.
Okay.
We have unlocked the box and removed all the pins.
I can't find out where it's coming from. I can't quite sure.
Now I'll show you a little bit more up close of how the pins actually work. You see, as some engage, others disengage. Back and forth, back and forth.
Let's get back to it now that we're all updated.
The strip here is always engaged. And now I'll show you how the pins actually work by spinning it out. And you see all the pins disengage, and the track in the center is clear, which allows for the box to be opened. If you like this video and this box, please like, comment, or subscribe. And keep watching. We've got more coming. Even more today, actually. Thank you.
That was strange. The terrible do. Okay. Really bothering me. Okay. At least we got band music. All right, back to the we're doing in here. Very sorry, but happens live. Okay. So what we're going to do is I'm going to double click on the sketch. What I can do so that I can have my design intent together here. The 657, I don't want to do the math. I could do just do the math of 0.984 minus 3 millimeters with the IN in here. That would make it so that we'd have 1.5 millimeters on each side of the diameter, and that value would come out to 6 there. But that's not going to help me if design says, hey, we need to make this thicker, bigger. Let's make it a 1.25, a handle grip. I give an okay. That 866 doesn't update for us. So, we'll do is I'll bring this guy back down. We'll go to, we'll keep it there and then we'll change it. The 866, we need to just update it. We just need to double click it and add an equation. You can add equations on the fly if you're not unaware these days. Been able to do it since about 2015. But I'm just going to say equals this minus 3 millimeters. Okay, not working. Sure. Equals this minus 3 millimeters. It's not like in the MM, as you can see. So I'm just going to put 3 times 3 divided by 25 point. I mean, I just did this. This thing is all going to crap. Match this. Everybody like how I'm completely off track. This has not happened for a long time. All right, get this one. Let's see if I make it equal to this, and then I'm just gonna subtract like a 1/4 inch. Just not accepting anything, which it Q, cool Q. And we are out of this. Let's come back to this. Let's see if we can tweak the code around there. So we come in and change this back to its normal size so that it doesn't else on this. Or shrinks up, gets thickness, and we'll come back to it. Okay, so what we need to do here is add thing is good. Actually, music, herbal music. All right, it's actually music from YouTube video. Could not be in there. Particular playlist. All right. Right, so what we're going to do, let's get back on track here. Come on, Neil. Get with it. Going to add in the other dimension needed for this guy, this piece, the 2 welded pieces together. So let's come in and going to add them in. In the 3D sketch that I already created. In the weldments, it is not necessary, but it is very useful to Continue to use the same 3D sketch because you're just choosing the lines that you want each profile to be put onto. Jumping all around for some. Come in here and we'll deal with on how to work with this. Since we worked on one plane, it comes right in here. We look at it from the top. We'll take that line and drag him around, and don't try to attach him anywhere or anything. Just dragging him into place a little bit and putting it on based on our dimension. Zoom in here. Look. So we have pops out. The center of it is completely vertical or in the Y here, and it pops down 1.5 the top, and it puts it in place. Let's do that. Get it in, start putting things in place. We will get our dimension command, go from here, use our tab key, get what we need, and a 2 tab. There we go, 0.5. And I'll say that this endpoint and this point, notice we don't have horizontal vertical, we have along X and so I'll say along the Y. We know we're along the Y because of off. So buddy, we can see our UCS. It shows us where our Y or X and on our what normally would be horizontal vertical. I'll say it's along the Y, pops it into place. And then we need to finish up with where this guy sits. So here, point to point for 3D sketches time so that I can use my tab. That guy is 3.4. Gives us exactly what we look at it from the side. It pops out like we're going to be changing the pops it out there. And then since we need the other side, we'll in the mirror. And about plane in the middle, which is our plane in this there. Okay. So now when I rebuild, we're just going to have that 3D sketch showing there. Turn it on. And from there, we will add our other profiles. So we'll go up into our structural members because we're using a different size. If I added this geometry, we were going to use a different size. I mean, the same size tubing as before. I could just edit this feature, edit the last one, and put a new group in. Start picking through here. And what this does when you do the new group, it's not only adding them in, but it's also doing trim for us out of there. But since we're using a different one this time, or different size, and we create a new one. I may be incorrect on that. I don't want to try it here since I've already punked up so much already on this stream. But I'm gonna put it up in here. Right now we're using the same size, but we're going to update the size again. Actually, we did change it, so ready. We'll give it an OK. And from here, we can see here if I hide this body, it did not trim it. I'm just using the tab key to hide and shift tab to unhide. That works for in assemblies and in multi-body parts. And we'll come in there. Now we have our second one here. And we will double click and we'll change this to correct sizes that we're looking for, which is 0.840 diameter. And this guy, let's see if the equation works here, equals this minus millimeters. Now I did this all before we started out, but not today. So I'll just do, I would probably make it something else, but 840 might 840 IN 3 mm. and then we'll here and rebuild. All good. Okay, this is what I was talking about. If we're looking from the side, yes, it could be designed that way. And from here to here is a... So the other thing here is, again, we're not trimmed up that we can work it properly. So as last week we used the indent tool because we did not use the weldment tool. This time we're using the weldment tool, so now we can use the trim extend right next to the structural member. Pretty simple tool. How do you want things to butt up? If you're using square, do you want them on top of each other, with miter, without? And in this particular case, just trim the ends based on what I choose. So bodies to be trimmed, I need these two guys to be trimmed. And the trimming boundary, how do we want to do it? Do we want to use just a facer plane? So if it were square structural members with rounded edges, which generally they do we want to have it cupped in to that particular geometry? Or based on just the plane that's selected, just slice it off as if we were cutting it on the bandsaw. But in this particular case with round, we're going to do it based on bodies. We're going to base it on here. And there we go. The this is what I was talking about here. And you can see here with the round bodies I was talking about, how would you get cut. Okay. But in here, notice if I have it here earlier when I was drawing it up to sure I do this properly for you. It was taking this end and extending it down, and taking this end and extending it down over here. Not sure if it's based on where I selected or whatever, but unchecking the allow extension fixed it for me. So here it's not doing it. Actually, if you take a look right here as I click the button, you can see that it's doing some math and kind of doing extension. I'm not going to allow it. Give it an OK. Now when I hide that body, we have two separate pieces. See in our cut list here, we have the pipe that I've hidden and the two other here. And this guy gone. The shadows off. Illusion. All right. That basically is what we wanted for the original design for the handlebar. But let's change it up a little. Okay. Take a look at our drawing. We have this drawing here is what we've drawn up. I don't know about you, but always design changes based on what you want or something. And we want something like this now. It's a little cleaner looking if you ask me. We need to add some knurl. Pull it in. We're going to add some knurl in there. We got a simple knurl. Of course, we're going to model it. I'm giving some extra dimension to show some dimensioning techniques. Of course, on a knurl, nobody's going to measure it. There will be possibly a major OD or something on something, because this is going to go into the gooseneck. Why would need to say it can't be too big, or else it's not going to clamp down properly. And then the major design change you can see here, it is not popping out the front anymore. It's now defined a little differently. It is parallel or on the same plane as the guy here. So let's, now I switched back. Let's go back and we'll update the 3D sketch and get it to update. And how do we get from that Y to making it so that we know it's directly lined up thing? Because we can't use parallel, because it would take, if I said this and this to be parallel while I'm in the sketch, of course they would make them parallel. We need 3D space parallel. So let's get to it here. In here, first thing we need to do is take that endpoint and take that along Y and press our delete key and get rid of that guy. All right. We've got an on plane, which is making it in the center from when we mirrored it. All good. And then we have our distance that tells it it's 1.5, which may or may not fail, and we'll deal with it if it does fail. But right now we're going to leave that there. So what we need to do is we need to create a plane in the 3D sketch, so it's not your everyday features, reference geometry. Notice available here. We're going to be using our 3D sketch planes. A little bit last week. Again, they work pretty much exactly the same as the regular reference geometry planes, but they live inside of the 3D sketch. They are accessible outside. Turn them on and turn on your sketch. You can work on them outside of the sketch, but here we're not going to do that. Here, if we look at the side, we need to get this guy in. So if we pull him in, all good. We can fake it all we want and get him in. I prefer a design that's correct. Brown is keeping that 1.5 inch length. Okay, so what I'm going to do is, since the plane option used to be in the right click here, doesn't exist more here. Not. I used to love to right click and just get it, but I'm just going to hit plane here at the top. Plane, and we can see a different plane icon. You can see there's our normal plane. Here is our inserts a plane into. Click it. Gives me a preview. Asks me for up to 3 references. I'll say this point, this point, this point. Get my 3-point plane right on front of that thing. Give them OK. It goes into the grid. The grid allows me, if I wanted to start drawing here, I would actually be drawing into on that plane in the 3D sketch there. But we're just going to use it for geometry. So I double click outside of it, and I'm going to view my 3D sketches here right in the middle. See, it sits in there and it's right in there. And I'm going to take this point and the plane. I'm going to use a relationship called on plane. So the point will have to stick to that plane at all times. Lost it. More we freeze up is all it comes with. Where is our relationship? At here. Good. All right, so we'll get in there. Plane 3 here on plane. There we go. So now when we look at them from the side, we can see it's lined up perfectly, not by eyeballing, not by creating a bunch of geometry, by creating a plane referencing previous geometry there for us. And here we go. We will close out, and it will update everything. And here is the issue that we had earlier. The extension parts. So we'll go into our trim that we created this with and fix it. And earlier I just not allow extension. Pretty. Let's go around the bug that's going on and see if we can just trim extend. If this doesn't work, then we'll put it back in. So bodies to be trimmed, this guy and this guy. Do it by its own. I think we have to do one time. I don't think it's it. Trim this guy with this guy. And I did nothing. So that is a bug going on there. So out, put it back in. Trim extend. Sorry, structural member. Member is the last one we used. And we get our two bodies again. What I love about live. It's just love and hate it. All right, again, we need to trim it off. Delete that last one. And delete is not something I prefer, but it was a very thing this time. I'm just going to trim one at a time. There's our extend. Do not allow extension. That is crazy. So. One I did 15 minutes before we started the stream. Here in the trim. Trim the two. Allow extension is on. I'm going to try that and see if that makes a difference. Didn't make it. Close this one. And let's see if bodies of trim. 1, 2. My body. This. Right. Well, there's more than one way to kill this. We can still use the. That's what we're looking for. We can still use the indent tool. We're just creating geometry, so indent again, as we used last week. Shouldn't have to, but target body, my tool, gonna cut, 0 offset, okay. Do it again. And again, it was under the features toolbar. Body, cut, hide this, and I will bodies you, right click, bodies. Oh, all right, that's what it should have created, but we still have two separate pieces. They're exactly the same. They can be flipped around. That works there. All right, we will show and hide. We got 8 people. Guys, for coming. That guy's done. Fix there. I'm gonna put the drawing up. We'll start a drawing of this. Let me save it here. I'll let handlebars live. Apps in here. Piece. Right. If you haven't noticed in chat, we have a lot of sponsors. This is somewhat part of our Orange County SolidWorks user group that's going on here. And they, these sponsors send stuff and sponsor us to help us with prizes and things like that. And what I would like to do is do a little giveaway. What has to happen here is you have to be following so that you can type in the chat. I think you can type in the chat anyway. But I prefer the follow would be wonderful. And it will allow me to do more things, more followers, the channel. And we'll do a quick giveaway. Here I have tools with here that I can do giveaways with. So I'll give you guys a keyword. You type it in chat. It will enter you into the thing. And then from there, we can exactly do that. All right, let's get Streamlabs here. Do a giveaway. You guys for that? Is happy? You want to give away? We got. What do I got today? Got. All right, for your quarantine drinking, we got for our first giveaway. We have got a SolidWorks water bottle. Pretty cool, my SolidWorks water bottle. And you can have that during the day and keep hydrated. And then in the evening, we've got the wine opener, bottle opener for your beers from DriveWorks. So we've got SolidWorks Go Engineer and DriveWorks here, giving us some giveaways. Go from there. Let me get the little thing so I'll give you a keyword. I need some participation here. I know we got 9 people, so we're gonna need at least half of you to enter. I don't need 50-50 chance. That kind of sucks for play. Come in here, and my first time I've done the giveaway. All set up. Let's see. What will also need to be done is, if you win, there's something called Whisper. Basically, pick my name, or you do at expand in the chat, and then type. I'll need your address to send it out, or you can whisper after into the Twitch channel, and I can get from you or to you back. But you have to have a follow here and follow. I'm not sending anything to you if you're not following. It's not yeah, wait, there's nothing on the screen yet. I'm still freaking looking for it. I had this all set up, and then everything died. The whole machine died last night, of course, because there it is. Okay, so in chat we will type keyword of sponsor, SPONSOR. Give me 1 second to in here. Sponsor, and type in that keyword in right up here on the screen, and so type sponsor into chat. We'll enter you in, and from there give away. So there's no extra anything to anybody that is not following or not, subscribers, anything like that. Chris, I think that is. Where about you spelled? There you go. So we got 4 entries so far. Right. Nightbot is one of them. Out there. Tough time. Give it another minute here. Thought that was you, Chris. Welcome, man. Here. All right, let's roll it and see. Yeah, you got a 25% chance. It's Maiden Mom. Awesome. Thank you for coming. For Mindy. Let's give away another set of it. We'll do one more. Look at that, Nightbot's in there. But it's not. Nightbot's not allowed to win. Nightbot is the one that is telling everything about here. It's the background bot. Looking for you guys cussing like that, but I got most everything. No cussing's allowed. Let's give it another giveaway. Giveaway again. Let me roll it again. Yeah, Chris. Chris, you package, and congratulations, man. If you know how to whisper, go right ahead and whisper it in there. Otherwise, later on I will whisper to you, which will give you something in there, and in your Twitch channel, which is kind of like a chat, get your address from you. Do another giveaway later on. Be the only one. Now I'll keep this page open. So check out. Doesn't take forever, and we can give a different one. Glad to see you guys in there chatting. There it is. All right. Best not to screw this up. Thanks for the vision, guys. Again, like I said, we'll do more giveaways later. Hope more people will be here. Of course. All right, let's get my round going. We got problems? Yeah. Congratulations, Chris and Mindy. Okay, let's get back to this guy here. And we will start our drawing for it. Drawings are a pain, but we can do it. Actually, before the drawing, let's throw on the knurl. Get up here on the screen. It's not big thing, but just getting pieces drawn like this, or representing knurl if you need to. The easy ways to get it on in quite a few different ways, and none are really wrong. You're just trying to but need to represent it. Maybe you're 3D printing it or whatever. So basically I have 3 degrees in between each notch that goes on here. It is a 1 inch over. I'm actually just going to offset a little bit off of the center bar and put it in there. And it is here. It'll be about 2 inches. We'll be updating that when we do the gooseneck. But from there, we'll deal with it when we get. Bandwidth keeps going up and down, literally shot in half. Sorry, 5,000 kilobyte to 2. Okay. Look at that. 2 weeks. I'm finally getting this. All right. Size of this. It was 840. All right. So neural. I'm going to start right in the middle. 3. Start a sketch. And first things first. To get the size of this being a tube, I definitely could grab this tangent edge and use a convert, and it would steal it in here. The reason I need that for some construction geometry, for the little upside down V that we're going to be drawing on here. I also need the circle size for the bottom of it, so and it extrudes out what we need to show. And then we'll create some other construction geometry. So, but my main point here is choosing this tangent edge definitely is doable on this. We know it's tubing, it's never going to change, but our geometry isn't always like that. It may be smaller, bigger. This may not exist. There may be a big fillet in here and it changes the shape or surfacing. Who knows why, but we need this particular geometry where our plane is going to. So it's a tool I like to point out. A lot of people do not know it's there. They don't use it enough if they do know it's there. But right underneath convert entities, there is one called intersection curve. An intersection curve, what it does is if you are in a sketch already, between the plane that you are working on and the face or faces that you choose, it will steal that profile right at that particular point. So basically I have this face selected. We are working on that plane 3 that is going right through the middle. And when I give an OK, it steals that geometry right in there. In this particular case, since it is a perfect circle, SolidWorks sees my steal as a perfect circle. Regardless of the shape, if I did it again, or I would have done it all at the same time, notice if I would have picked this, given OK, it stole that section there. Actually, it's seen line because of what it is. It's not actually circular there, it's elliptical shape. Not 5 degrees. So you can steal anywhere you want. Now, how is this going to help us draw Earl? Just construction geometry for right now. I'm going to take this particular piece and offset it. Offset it about 0.5 millimeter to start. We'll see how that looks outside. And I'm going to start throwing in some. So let me go normal 2. Is also usually I choose. I usually use 1. And we'll come in here and I'll just start throwing junk in. Line tool. Here, and up from the middle in this particular case. I'm going to draw a straight line, which will turn to construction. Window select the 3 pieces and call them symmetric. I'm going to take this outside geometry. This is just so that I can control how high the knurl is. And I'm going to turn it to construction geometry. And I'm going to trim off my power, but save that part of that was converted or intersection curve. So did intersection convert? Section. Yeah, intersection. Okay. So it puts it in here. The drawing said I wanted 3 degrees in here so that I could have an even number all the way around, or actually 2.5. I think. Didn't places show. So I'm gonna go from point to center, or to point, and now I can throw in right here, right in the middle, 0.5. Oh, that's do. I know what happened. Go here to here. And 2.5. A lot to get 2.5. Okay, so on the drawing, even though we had this construction geometry in here, on the drawing, the dimensions are going to look like it's coming from the point because here. So that is at least a mindset of mine out for us here. From here, we have a single closed profile. Need for at least a full extrusion. So I'm going to extrude it mid-plane, as we would all guess. Pick it. There we go. And the drawing told us that it was 2. Now, as you would guess, actually, there's one other thing that happened here. Because this is a weldment part, you know, with the weldment feature, which is right here in our tree, it doesn't, or it makes everything not merge by default. Unlike a regular model, everything merges by default. So when we look at this extrude did for the case, it says they went to merge results, which is screwing with me. All right. Normally this is undone and it would just be a body sitting there, but we can see here actually now the whole thing is one body. That's weird, unless I subliminally did it, which I don't think I did. Oh well, whatever. All right, so what we'll do is we'll come in here, we're going to do a circular pattern. If you got some weird, in this particular case, 2.5, what is 360 divided by 2.5? I don't know. I really don't care. Because we'll just let SolidWorks do the math. And let's say it's around here. And if the 144 wasn't already there and just said 2, we can just say 360 divided by the 2.5 degrees. It gives us the 144. Maybe if we want a tiny little gap in between them, we can pull one out or a couple out. We'll make it an even 140. Give an okay. But it looks like it. We could do more to it. Why waste more time on it than we need to? And if I wasn't explaining it all, it would 2 minutes to do that triangle. And let's see here real quick. Let's see. Geometry pattern is on, and geometry pattern is, I don't have full explanation of it, but it does save memory. It doesn't have to try to keep attaching to the faces around, is the way I see it. It just keeps the geometry and goes. Says I don't really care what's under me as long as I'm able to stick to it one way or another, and go from there. So geometry pattern unchecked would still go, but it would actually probably be a heavier feature, and we can check that out if I uncheck it here, because we have 140 of these. It's not just a simple 2. So if I change it to uncheck it here and go to evaluate, I'm just getting into a little deeper on how to make your models faster. And where's I go to performance evaluation. It's going to look at all the features. That circular pattern is actually taking 70% of the rebuild time. It is 0.88 seconds, but if this is your normal thing, do and you got a large part and you're doing this over and over again, at 0.88, notice everything else is less than a quarter of it. It's 20% or less. It's taking up most of it, 70%. So let's see, if I edit the feature and just check that checkbox when able to. Okay. It's gonna tell me I can't do it now. Oh, there's no scope. I don't need it. All right. Accidentally unchecked it when I checked it there. Hit rebuild. And let's see what it comes out to be here now. Now it's only 0.55 seconds and 58. So we saved 30% of the rebuild time. We're down to 0.94. And I know the 0.0 seconds is not killing us. There were lots of these assembly, or you're doing this and you're taking that 0.3 seconds times 500 parts in assembly. That's your assembly rebuild time blowing down, and you're blaming SolidWorks, but it was a simple checkbox that you did. There's a million of these things in SolidWorks on how you can build things, how you can relate things, pattern things, mirror things, fillet things, and save time. I'm glad you like the chickens too. I have llamas too, but they're barn. Dave. They are in the background eating at the desk too. All right. So we got that on there. And now it's time to make the drawing. That could be difficult, but it does not have to be. This thing. To at least get 95% mark. That's what I always teach in here is get into the 90, the 95% mark like that, and dealing with the last 5 to 10%. I can do that. So, come in here. What am I going to do? We're going to start our drawing. Save this one last time. So it's amazing. This 5 hours, not today, but total time with you guys, and not one SolidWorks crashed. I mean, that says a lot. 5 hours in that, but switching around, doing all kinds of things, and it's live. Back in the day when I started, SolidWorks would crash quite a bit more. It's been a long time, but still. All right, we'll throw this guy in here. Here's our front. All right, and notice the temporary axes here that were turned on last week. Now when they come in, it gets rid of the temporary axis. And here's a little tip for you. I want the ISO. Put it over here. I want it over here, but I can't get it there unless you hold down the shift key. I'm sorry, control key. Come on, Neil. There we go. Control key. And it allows you to get anywhere you want. On my cursor for some reason, but on over here. You can do the same thing when creating a section. You hold down the control key or shift key, I'm sorry, and it will for you. All right, when we finished the tool, it took away all of the tangent edges, which we talked about last week. And if you go to options, if your tangent edges are showing up on your drawings, you got to turn them off every time, or you're just dealing with them. I can't deal with them. You can go right into help. We now have a search, and under drawings, display tangent edges, click on it. You can make it so that tangent edges are removed for new. Of course, you can turn them on, but I don't want to turn them off all the time. And then once you do that, then you would, with a blank drawing, do a save as, and save it as right here, DRWDOT, and overwrite your previous template so that the setting. So like for here, for ISO, I prefer, especially for a view like this, to have the temporary or the tangent edges turned on. We can right click and under tangent edge, say, show it with the font. Ends. Okay, so we got our views, got an ISO on there, real easy. We named the description when we saved it, so handlebars live. That's what we called it. So I'm going to insert model items as we talked about in depth last week. See it on the last on the archive videos. And there's the dimensions pushed in. We haven't used any hole wizard stuff. So basically, let me do this live for you here. Insert model items, enter, enter. Give it a second, and your dimensions are there. Okay. Somewhat of a mess, but at least most of my work is done. Guy up here. Up. Good already. Grab one of these guys. Down. We're good. Up some. Here. Here. This 20 thousandths is the offset from the knurl, and if I delete it, press delete and do more design changes, then ask for the dimensions again. Guess who comes back to visit? Mr. 20 thousandths. So I right click and press the letter H or hide from the list, and now I can insert all day long hidden. So he already shows up in the code on the drawing, but it's just not visible. Here, come. Bring it down a little bit to places. One place, curl. I'm a note. Oh. Left. Top. Pretty. Now, these aren't really helping right now where they're sitting because we don't have center lines or anything showing what. But and this, not sure how we would define this. This 320, 429 probably would number, but here. Okay, the whole sizes didn't come in. I'm not sorry, not the type size. And we'll deal with that in a few. We actually won't need it on here because the cut list will show. But let's deal with the center lines that we may want to show because that's where all our dimensions are going to. Center of the. All right, thanks, Stephen. See you next time. We'll come in here and like we did last week, I'm going to say this is drawing view 1. So we see drawing view 1, bring it down. There's my 3D sketch. I'm going to pick it and convert it. Seals them all. I didn't even show the sketch. I just picked it all. And now there's all my geometry. I don't want it as lines like that. It looks like it's messed up drawing. But if I right click, now I can select the chain and change it to construction geometry. Of course, I could change it if you use layers. I don't like layers, but change layers. You could make it a different color. You could change its thickness, whatever you want. And line. I can also take this end, drag it out. Like anything that's converted, you can grab its end, make it longer, and tweak it from there. Guys here, we're not part of the chain. Now we got center lines. Got if we intersection, like for this dimension, I'm only going to do 1. But if I pick these two, where I need the intersection between them, pick the standard sketch point tool. It actually will throw a virtual sharp in there. And for your company, just so you know, there are multiple virtual sharps. You can only have one type per drawing, which is a downside. But we'll say virtual here, sharps, and here's where you choose what kind you want. Under that drawings type, virtual sharp. So I'll just change it to witness. Hit rebuild. There we go. See that it shows you the. Get whatever you want. I forget. Actually change construction. escaped instead of okay. So we can get in there. You can put in all the virtual sharps you need and things like that. But essentially, drawing is very cleanly done. We don't have any call out for the knurl. Go, and definitely we don't need, like we have in drawing here, we don't need this, but I just want to put there, you guys know how to get to that point. Show breakaway section like that, as you can see here. Zoom on it. F. We can see we have a breakaway into the geometry, into the knurl area, without having to make a whole section, and then we can call out whatever. So do that here quick. To do that, zoom on in up here, and under view layout we have something called broken out section, where most of you used it. Automatically throws you into the spline tool, and you draw that you need, or the shape. Outside here doesn't really matter because it's not shown. It's when it gets into the actual part. Hold down the control key in this tool or anywhere you don't want to accidentally grab relationships. I held down control while I was in the middle, so that I didn't grab any edges that particular shape. And you can do that also when you're drawing lines and things in a regular sketch. If you hold down control, it cancels the auto relationship option. And so our depth is, I'm going to attach it to right onto the edge here. I'll just pick with the edge of one of these things. It'll attach parametrically to the edge of that versus me putting in some random number. Turn on preview, we'll be able to see how far it'll go in. Go. Or cut in, right into it, and I give it an OK. The hatch doesn't look quite right, so I'll pick that area, the hatch, and uncheck the material crosshatch option and give it a few more lines. And then make a detail view. Kind of a one of the new detail views that we have. To come in here and throw in area that I need. By default, it's going to come in. Whoops, come in my. There it is. Per standard will come up. Give an OK. That is not my standard. I'd like to look like that. My option says per standard, which is circle, not updating properly, but I want these to attach to each other anyway. So I am going to come down in here and say that I want it with leader. Sorry, connected. There we go. And this is one of our new options, jagged outline shape display. You can show it however you'd like, or uncheck the jagged line and have our normal circle here. Too small, so I'm gonna come in here and say, hey, I need it 1. Go, that'll work. And kind of show this kind of whatever you want. It's up to your. And then I will pick this, insert model items, give it an OK. Yes. Should bring it in. There we go. There's our 3 degrees over. Should be changing it, and that's kind of a sucky thing with SolidWorks or on this tool. But like the other drawing that I did. 2.5 degrees. I can then again come over here and go to my detail and grab it down to where we did the thing. And this time I'm going to show the previous sketch and take this geometry. Very weird. Pick it and like it's highlighted. And then I'll hide the original stuff. And I will just up here, I'll draw a line here, here, and I'll change the construction. I'm just gonna get it so that I can give an overview of the max height or something like that. So I'll bring it in here. Also allows me to show one other thing here. Call it max. Let that as arrow. Okay, I'm going to bring it down to one place. And the other thing we have here is it's showing a radius. That's because we started with a piece that was not not a full circle. That's why we get radius. But if we pick it here, we pick anything that shows radius, whether it's in a sketch, not, pick it here, and under liters, there's the radius, and here is the diameter. It will put for you here. This probably, it can't be measured anyway. There we go. So relatively quickly, probably in 10 minutes, explain it all. We a drawing that is step 4. We don't know the material yet. Holding down shift so I can move. In here. So what we need is a cut list for this. We have these two are the same, so we have one here and one here. They all need to be manufactured, and then we don't have any weld callouts either, but we're not going to deal about that. Class here. Okay. So I'm going to just pick it, one of the views, it up because, and under tables, off the screen. Tables, and then we're going to bring in a cut list. I'm showing this. I know not all of you are using cut lists. I don't use it very often either. I'm going to give an OK to the box and place it down because right. But notice it's empty. We used the weldments. We should get a cut list. Why is there no cut list? And this is why. Take a look at that. We have a cut list in our tree here, and but it's not. It just shows the bodies, just like it's basically changed the name of solid bodies to cut list. But if we right click, there's an option for update, and if you save your template with update automatically checked, then no problem, it automatically makes it good. But if you find issues or you're getting what we do, there's no cut list. You choose update. Before I do, I want to point out that there's 2 indents, which we know are the center pieces here. And then the circular pattern, which is because we did the circular pattern up that name. But if I right click on this and choose the update, like I said, a second, and it finds everything that matches, that is not opposites, like that, and puts them into their own list. So now we have cut list of the middle pieces and bottom piece. Here. See, there's that and that. Because they match. Gonna bake this in real quick to show the actual intelligence. This and this, if they manufacture 2 of them, they will weld together at this angle and they will fit right in. We do not need the left and right hand version. But I'm just going to do a simple cut here just to intelligence it has. Put a circle here and cut through this one. Circle. Cut. Okay, so now these are not exactly the same. If I hit rebuild, it is not fixed over here. But if I just say cut lace, it automatically update. Not taking much memory unless it's huge. Now it knows that it needs one there, main body. You can take it further. You can create sub weldments that might get weld first and sub of it. Shows them broken down. So I'm going to leave this way here when we go to the drawing. As soon as we go to the drawing, we don't have any, but it shows that we have three of them. Cutlass piece, and then shows the length of each one as we talked about. So we got 26.8 inches long for the main body area, grip area, 4.606 going there. Also, we changed those numbers of the diameters. It also updated what stock also. If I go back to the drawing, actually we'll come in here. I'm just going to use the everyday balloon tool that you use for your assemblies. I need a balloon here. There's number 1, 3. Guy off here. Okay, so you can label them for what's what for manufacturing. If we come back in here and I take that cut out, your sketch also. Everything okay? What happened here? It automatically updated because we have the date checked. And now 2 and 1, so now there should be only 2 items for our cut list. As far as our 2 items, and its sizes independently on the stock needs to be purchased or bid. 1, right? And one last thing here. It looks like a happy little guy. Little guy. But if I take out one of these balloons and I want to do them both, many people will just take the note tool and point it here and put it in place and then not give the note anything. But that's not the correct way to do it. If you just pick and you need a 2nd, 3rd, 4th, 800th leader on it, you hold down the control key and grab the end of the arrow, it creates a 2nd one. And I'll put it on this edge here. And on the edge, notice your highlights of your cursor, not necessarily where it is. There we go. And now we have 2 leaders that work together basically. So now we have, other than weldment callouts, things like that, a pretty complete drawing. All right, if this works. We need to give a color. We are saving all these parts. Eventually we'll be assembling and things like that. So think on your screen if this works like it's supposed to. You should be getting a pop-out site to vote And what color should we do the handlebars? Should we match it to the frame, or should we give it a chrome color? It pops out. Wait for that pole to go through, and what you guys got at the top of the screen on there. Should pop out for you guys. Doesn't. How this thing's working, but it did work out. Pop out, and there's a little vote now option. Got it. 100% chrome. We have another minute. We'll start talking about what we're going to do, and then we'll okay. To save this drawing. Background. Talking about later if we need to. How to end it. Trying all these things out. I got this thing to make stuff. Figure out how to like end a pole. So we got chrome. That's what we'll do. Guys, for picking it with. Let's get easier and easier. All right, now it's coming. All right, thank you guys for voting. It's awesome. Let's we're gonna do forks real quick. There's a lot of the stuff that we did in here we'll be doing in there, and then we'll let's go to the frame that we had earlier. Let's start an assembly for this project as we'll after week on. So I hit the R key for recent. You can also filter now in 2020. I can say just show me assemblies, just show me parts and assemblies and so on, just like when opening stuff. My parts, here's our live frame. Take this guy and we'll insert him into an assembly from him. We will pick this guy that hold for the split. Snap him down to origin. And let's bring in the next one this way. Insert component. Our handlebars, we'll drop them in. Press my hotkey of O for origins. Somewhere in place. For those that are unaware, when bringing parts, the right click, slide will rotate apart. So we know that if we grab it with our left, we can move around, but right, it's better what you're looking. All right, I'm just going to save this. We'll be building this over the weeks to come. Or cycle. Child. Bicycle. Okay. All right, we'll turn off edges here. We'll give it a background that we'll be able to see nice chrome as we come out. I don't really love this one, but it'll work for this. All right. Here, minimize them for now. And we're going to get into our next model since we're done with our handlebars. Anybody pick, can you tell me in the chat anything you picked up? Anybody picked any tips up? I'm going to do something quicker or been using more, things like that. Let me know in the chat to be on. Close up these guys and have them saved. I'm going to start a new part. Here we are. We'll take a look at what we're going to be drawing next, which is keep looking at the actual live feed out there. Got to end the poll, which normally is. All right, what we have is the forks next. Pretty simple. This top area with the thread, top area with the thread here, we are not going to be doing today. I want to take a look at forks. I was looking online. There's quite a few different ways. So based of how threaded area to get the gooseneck on and all that kind of stuff, and tighten it down is different. So I'm going to do a little research on that, and if anybody has anything with what I'm looking for, any insight on forks and bicycle, great. You can into email. You can send it to ncustard@catexpand.com. There, you can refer them to Twitch at any time. But it's basically, this is if this were a weldment, we're going to build it that way. We're doing a lot of weldments. There's lots more parts of the bike that are not weldment. If there's any sheet metal, but we'll see. We have two pieces here. Let me zoom in here if I can. There we go. The two welded on pieces here, these bent pieces that get welded onto. And as I said, the top threaded part at this point, we're not going to draw that today. Have it on. We're just going to draw this up. We'll throw it in the assembly after we make a quick drawing of it. Or in chat, if you guys don't want to do the drawings on this particular one, let me know. We don't have to do drawings for everything. I already have them created. Of course, we're building from them. And this is the last part we're going to do today. We'll answer questions at the end if you got any, or throw them in while we're going when you have them. They're live. Okay, so our main thing is we need the main body area here, which is got an offset down below, total height, basically not an offset, but where the fork areas come. We'll get into caps in this particular one, capping off ends of things, the 3 different ways that it can be capped, and move on. All right. So you guys don't need to see all the dimensions. You trust me that I'm putting in. And I remember to. All right. In the last tool, in the last the handlebars that we built last, we had to create a 3D sketch, and we did the weldment. And in 3D sketch, I mean, the weldments work in 2D or 3D or both. It doesn't matter as you're building. So I'm just going to start a sketch on plan 1, which is our normal, our ISO, in ISO. And I'm just going to draw a little stick figure of we need. So guy up here, and do that offset here. Yeah, I'll draw a line. For those that aren't aware how to go from a line to an arc, you can use the A key, I believe. My A key is always something different. Yeah, I don't think I've changed it. Oh, A is for axis. But if you're drawing a line and you go back to the beginning and come out, you get a tangent arc. If you come in and go backwards, there's tangent. There is a way. There we go. It's not tangent. It's popping out. The A key, if it is still on your keyboard, if you didn't mean to do that, you just kind of went back to the A key will switch it back to it. If you're like me, that hotkey doesn't exist anymore, you got to just escape out and go back to the line. I'll put this guy here, down. One thing I'm looking for here, because I drew that arc, I'm looking for my vertical icon there and the tangency, getting both of them. If I was off a little bit in any way, or escape out here and go back, line here to here. If when I put in the arc, there we go. If I put in the arc and I wasn't quite straight and I wanted it, there's my vertical, but it's not tangent. You got to choose one or the other. I'll choose the tangent, and so that I don't forget, especially if it's close, I'll just pick the line out here. Okay. Come in here, we start throwing some numbers on. Get some scale to it from here to here, 1.181. And hopefully everybody's noticed, it's been quite a few years now, but you notice the screen didn't change at all. If you've been using SolidWorks for 10 years plus, that 181 may have made it super tiny or huge on the screen, or who knows what. SolidWorks automatically does view scaling based on your first dimension. So I've thought over the last couple of years since it's been out of that first dimension, how you want that whole thing scaled. Because I've done some that is the wrong dimension, and then the next dimension, like if this was a 1/4 inch, then I put this in 181, it might not when the rest of the go in, because the rest of the dimension, of course, gonna move around. Okay. I'm excited on this series that as we start getting into more design and changing things and tweaking things, get wheels and bearings and stuff updated. Okay. Doing the design changes. I take a center line. I'm just going to drop it in right here, just because what I want to do is I want to mirror over. So mirror entities. Why the select chain isn't there. Here about here. Okay. That will allow me to get forks and the center lines for the that. This is you can never find them when you 120 degrees here. All right, and that fully defines our sketch. We have all the info time, and we're just going to close the sketch because this is our skeleton for, as I said, our weldment. We're going to go to weldments again. Again, this is not a weldments class. I know we did a lot of it in the last parts, but I don't think much more parts. I should be. I've had complaints in some speaking engagements where they're like, "You shouldn't be showing weldments." Well, I don't care about them. Some people do. I hope you guys are caring, or at least getting the regular modeling out of it. We're going to do a structural member. I'm going to come in here. I'm going to pick the. This is 181. I'm going to use the little bit bigger one. Our 1.181 is our diameter for all of it. Yeah, all three pieces. So in this particular case, on the handlebars, we did two separate structural member tools. In this particular one, we're going to do it all at all. I did find a bug earlier. We'll see if the bug is showing up here today, but we'll go in here. I'll say group. Group one is this guy, middle piece here, because as I build these forks in, I'll trim up to this automatic. And then I'm going to say I want a new group. My new group is this guy. And there's that merge arc center segment bodies that be done on this. And notice if I don't do a new group and I pick over here, it says you can't do this. It's not attacked. It's got this sharp point. So I'm going to say new group, you. Okay. And I can see the bug already, and I'll point it out. We'll work around. For some reason, it is trimming here. It is seeing where this could be coming through, and then it's trimming off what would be the bottom of its body. Not what I'm looking for. It really sucks. But it's 18 million lines of code, honestly, from what programmers plus. So things happen. So what I do in this particular one, where my only workaround I could find out before I got here, is I'm take out group and then use the structural member tool again. Now it doesn't have information on how it should trim this particular piece. So we can see it's trimming up into here. Should be able to use the trim extend tool. Actually, I think it trimmed it wrong again. But we'll say here and wait, body's too big. Okay, and by this one. Now it comes out proper. So little workarounds. The tool is freaking awesome compared to what it used to be. It used to be awesome and gotten so much better. So hide this sketch in the middle. I don't need it anymore for this, but we do need to change the numbers. And the downside of doing this twice is because we're just faking in the profiles. I have to do it twice. So this was 1.181 is almost the same size in there, and then this is the forks child's bike. So we'll do it this this equal this minus. Look at that. It lets me do it here. Exact same thing I tried to do. There must be something in that particular sketch. But I'll give it okay. That will change, I believe, both of them. One sketch that controls both of these group. And then this guy, what I'm going to do is I'm going to steal his info. Double click on this guy. seal this. Actually, I'm going to copy this one. And so when I go to here, second one that I did, right place. So my OD is to put this guy in here, and I'm just going to make it equal to the dimension on this one. And I'm going to double click on this guy and just put in the same equation. So everything's looking at that original OD here for this second one, since I had to do that workaround. Let's play. Now when I rebuild, everybody gets fatter. And here, 30 millimeters, or I'll change. It was using this, it's behind me, but when you click on something down here on the screen, behind my arm here, it'll show you lengths and sizes like that. And in my measure tool, I had it set to use custom settings, millimeters. And it was showing me millimeters even though my part was in inches. For me, but now if I choose use document settings, which is set to inch, I know you guys can't see it, but it says down there, if the zoom it all, but when it was set to the other thing, set it to it was showing me millimeters, so it's matching whatever's in your measured palette box. All right. We got the main geometry for this. We go back and look at the drawing. We need the parts for the wheel. We're not going to put in the little lightning holes in there. It's not necessary. And then, like I said, you're going to skip on the how it attaches to the top. We'll add that in probably next something. I will be making 3D prints of these. I'm assuming the forks will be colors, the bikes will that very red, I think. But in here, we need to plug these up. That would be welded little caps, not getting bugs and garbage in there. And then put on the part. Again, I forgot to switch back. So we're going to put end caps in here. And so the caps are real easy. You would think that we would start a sketch and draw a circle and extrude it up there. And because we're using weldments, it is going to not merge. And that would be true. But in our weldment tools, because we have the weldment at least in here, and it actually will only attach itself to actual things that were created with the structural tool itself. But we can say end cap, and we have 3 different types. We have where it's outward, basically welded on the end of here, and having some sort of is our thickness and what offset we want from here. I'm sorry, just its thickness. Go here, click here. It's on the outside. We can go inward. So it puts it in, and there's talk about in a minute here. Go inward, or make an internal one. So it's actually inside of the geometry here, and internal. That one has the double off. But we will have an offset value of like 10 thousandths. you're setting this so that we can get weld in there. That corner treatment, I cannot figure out when it is actually able to pick the box. I believe it's new, or I haven't noticed it before, but I can't turn it off and I can't get it on. So if you wanted to put a chamfer on here so weld bead could go in there. Now you can do more than one at a time, but there is a bug on this particular part. It's been on it first time when I drew it this afternoon stream, and now it does this offset. I have no idea why. Whether I do it separately by itself or with something else. So we're not going to do this guy, but we also can do this one and get them both plugged at the same time. Now here's a workaround. This has nothing to do with weldments, but when you need to get something moved, copied in a multi-body, even take the body you're working with that may be just a single part, but you need another side of it that can't be mirrored for whatever reason, moving a body, a million reasons, just you can let your on this. Basically, the reason I'm going to show it, I'm showing, if I choose the trim extend and I pick this end again, end cap, and pick the end, it's doing that, and it looks like, well, maybe the preview is wrong, but you give an okay, that's the cap it gives you. It's done it 3 for 3. Not sure what's going on. So I need this cap over here. I don't want to draw it. I want it to count it exactly the same thing. I want it to update with each other. If we went from 181 to 1.5 inch, then everything's got to update. So what I'm going to do is I'm going to go to our cut list, which we can see it's a template says not done. And I'm going to take this one here. And before I do that, so that was in cap 1. I'm going to come up here and type move. And there's a tool called move/copy, especially when working with surfaces, multi-body parts, things like that. And it comes up, it says, what bodies do you want to move? So this is for bodies, not features. There's, of course, sketches and things like that. And we can either mate things into place, or at the bottom we have translate, rotate. Use translate, rotate. I can copy. And this is not total number because we already have one. It's how many more you want. Unlike most other things in SolidWorks where it says what's the total number you want. So I want one more copy of this with 0 translate. It's going to complain and says you didn't tell it to do anything. Okay, that's okay. I don't need any extra background stuff on. But what all it's done is taken cap 1 and copied that particular body. And what I'll do is I'll just tab here. We'll hide this guy. I'm going to take the original one so that I don't move it, and hide it. And we can see that the move body copy one there. I'm going to take this one more time. I'm going to go back to the move body copy, move copy body again. And this time I'm going to go use the constraint side. So bodies to move. I copied plug, constraints. And now we're in basically a very low-end version of mating in assemblies, but we're using it with bodies. So I'm going to say this face and this face are concentric, and it's somewhat primitive to the mates in the assemblies because you have to hit add every time. So you see it there. You have to hit add before going to the next one. This face, coincident, add, and we can see that the mates they actually call them mates. They're down here. We can choose them. We can tweak them. And the one thing about these mates is they don't follow the normal rules of mates. If I say two faces are coincident, and then I tell it to be concentric somewhere else, just like we did here, and then I say make this face here coincident to this over here, override it, it kind of in order that they were created does them. So it actually won't cause an issue in most cases. It'll just say, oh, you want a coincident here? Coincident here. Oh, you want a coincident here? You want a coincident here? Even though it has 3 coincident mates, it's only caring about the last in most cases. So just think out what you need here for this. Once you're done, give an OK. And we'll see in our tools we have here. We can see here the move copy. That's our original, just getting a copy of it. And then we have the move copy that we just did, which includes the mates that are in there. We do with we can suppress the mates, has to be configurations, things like that, regular stuff. Which gives us, when I show all my other body, it gives us what we want. Okay. If I turn on my update automatically for our cut list, now have top piece, 2 side legs that match, and we have 3 end caps. One was copied. They're exactly the same thing. If I radius one, cut a hole in one, anything like that, of course it's going to create, like we saw earlier, a 4th item. We have the wedding march going. The weirdest tracks. Supposed to be rock music for 4. Color, we'll go back in. Painted our apple red. Works. Okay, we got the one last. We got these guys. If we draw them up properly, based on all the dimensions that are here, the center mark for the center for as high as the wheel can go, or based on its axis, be in the proper place. Unlike when we did the bike frame, it dimension as this far from the sprocket area. Sprocket to sprocket. So again, you guys trust me that I'm using the numbers on the drawing, and we'll draw this up. We'll put it in place. Create a separate body. It'll cut list. I think for this one, I'll just drop it on. I'll go over how to get that particular piece that we're going to draw right now out again as a separate piece drawing, so that we could detail it separately, so that they could be stamped out and machined and whatever needs to be done, and thrown in a box, held it onto this guy during manufacturing. So first thing I need to do is I need to get a plane that is going right through the middle here, so that I can draw there. So we'll go back and actually I'll turn on my temporary axis. Well, it looks like there's. All right, I'm not going to trust that. I come from aerospace, so I get a bit of a thing. So what I'm going to do is I'm going to show the original sketch. Show this. Grab this, and whatever plane goes right through the middle. There we go. 3. And then in our reference geometry plane, you'll get a plane that's at that point and is parallel. So I'll sketch out stuff. Let's look at it. Normal. At the right side. Draw it to the right. Okay, so try out a minor of the size. Oh. Boom. Actually, this line. Okay, for those lines, I want it to be based on this geometry. So again, I'm going to go back to my intersection curve. And I'm going to say U, because we're working on a plane that's going right through the middle of this leg. And this. And when I give an OK, it's going to give me those two lines. In many cases, in what I probably could have done, is I'm going to delete this. Could have brought my cursor right up to this edge. There's that silhouette. And I could have converted it. But again, all geometry is not the same. It could have been some weird wavy face that I need to loft with or sweep with or something like that. So it's not always possible. So it's actually, in my opinion, easier just to grab this tool here, intersection curve, grab it, okay. And in this case, nice. Side. Oh, that's the side that I already had. Actually grab both. Something I didn't know. Section curve. Yeah, that is another thing. Since it is round, the plane goes all the way through that face, and when selected, the whole thing's done. It puts it on both sides. Of course, you want to delete one down in here on both sides. Sometimes that's what you want, sometimes it's not what you want, but it's just like a converted edge. Now I can grab this guy, drag him in, and grab this guy up here at the top, drag him down, hide this sketch. Free sketch. On. And normal too. A lot of movement. Alright. Snap him in here. Look at that, close profile. You and you are linear. You and you equal. This guy is 10 degrees. So like we talked about last week, I could draw a little line here and get the 10 degrees, but we don't have to do that anymore. We just pick the line, I'm in the dimension tool, and then pick the end point and ask me, where do you want your, right here. There's my, okay. Total height of 3.5 inches. 3.1. That, back notch. I'm in 4.33. Got here to here. Got 1, 4. Down. Now this, we need that the round area for our axis, or our axle, of course. So I'm going to take this and just turn it to construction line. Yes, I could delete it, but if I deleted this always might. We also lose that this and this are the same width, so you have to be dimension arc that's going to go in. I'll throw a tangent arc right here to over here. It's even, puts it in there. And also our dimension goes, I'm holding down shift, bottom, and then we get it from the top quadrant for total height. Probably not what they would want. Do if I want it. Let's see, what else do we get? Guy slides out. So mention here. Got missing a couple dimensions on my drawing. But so control guy's angle. Solid 45 sounds good. Okay, I could put all the radiuses in this sketch, but I'm not going to. I prefer. I don't like that 40. Those. Okay. So he's about, I think, 4 millimeters wide, or 197. 4 millimeters, 197. Mid plane. All done there. And of course, we have this tangency issue here that we would normally get, but since we are not merging, and it'll be a welded on piece, it's not going to make a difference because that would be. Get our piece. Throw on a couple fillets. So we've got 157. Here. Anybody ever notice this box that pops up? Where you can pick a lot of the edges automatically. Go pick real quick. The box goes away, of course, if I Control brings it back. Alt. Select and select. In this case, it's not going to work for what we want. It's going to be too many edges. But sometimes when you just want a whole bunch of edges done, there's usually. And this is based on this geometry. It could. I've seen them pretty long with all. Picked. Not kidding you, hundreds of edges with one click to slow down while filleting, and you be able to faster. Here, okay. Little trip for you. This edge, I don't want it that same 190 or 157. I want it 787. You can take any cuts, extrudes, fillets, chamfers, and basically copy them. I take this fillet and control, drag it to the new edge or face that I want. It creates a second fillet, cut, extrude, chamfer. I believe those are the main tools that'll work. And then it's something new, and I can just double click and change it to the actual size that I'm looking for. Give them OK, rebuild, and of course it'll update and right in here. As a little tip, that's what we're here for. I'm going to delete both of these and show you under fillet. Multi-radius fillet. Right underneath where we've been typing in the radius all the years. Check this. Come in here. You and you. When you are 157. And when I give it OK, here we go. 7. Yeah, that's right. And then I pick this guy. It's going to put it in 157. But notice here, if I click on this, 157. See? The new edge that I chose, if I type it in, that's 787. Now, edge 5 is 787 and 4 is 150. So with that checkbox, you can update and have different size fillets in. So we have one fillet, and in this case, 1, 2, 3, 4, 5 dimensions. Sparingly use that one. I'd rather be able to express different size fillets if different configurations or checking out making something 3D print or prototype or press analysis. But we do have this capability. Of course, we put the lightning. Well, we're just going to take. It created a new part to our cut list. Find that mid plane here. Future of the design. And I'm going to take this body. Okay. Here, give them an OK. Solids. Now our cut list now has. Go. We could put in our weld beads if we wanted, since we have the weldment tool on here. Define our welds, make our drawings, get our cut list in there. Save this again. Put it on the drawing and go through the steps that we kind of took a long time on the previous model. Front. Tangent edges turned on. ISO. Hold down shift. Oh, sorry, control. I don't know why it's control, yeah. Control is usually copy. Place him down. If I wanted to make that separate view like we had down here, this, we will use, learned last week, under our view layout, have something called relative view. If it doesn't exist, like relative up here, there's relative view. You pick one of the views that has the part you want. It's going to open up the model looking, usually looks at it that way. And I say I want to select, and I just want this guy. Pick the one that you had the dimensions on, that's for sure. And then you tell it what, let's see, this is my front, body, and this would be, I guess, my right, this here. You hit OK, it's going to throw you back to the drawing, and in hand is the actual, just that body. You could pick multiple bodies if you want to fake in some sub-assemblies, something like that. And then, of course, this could be scaled, insert model, projected, of course, projection. Project, project this one, so whatever you want. Things, and then last but not least, gotta put up here because it goes off the screen. Drawing views, not drawing views, tables. Weldment cut list. What, four lines? Give an OK. Place 4. There's a way to give them all descriptions. And then just for our last thing, insert model items. Choose it, enter. Start cleaning up. Convert your sketches, stuff. Finish up and get. This is the downside of doing the multi one here, the multi piece, instead of having one dimension for our feature. Each edge has its own. So 7 here and that end. There we go. I'm going to control select these 3. Right click 8. Then I would label this guy. Just to point out our full live going through, since I put that 4x on there, those dimensions, all the dimensions are going to go on there, but one here is our 4x. Same exact thing. Go on DWG. Yeah. We can see This works also the same thing for tolerancing. So you might not have your tolerancing now. I like to do tolerancing this assembly. So while you're in the assembly, or in this case the part, you can start throwing on those. So this guy is not real important, so maybe limit dimension. Degrees either way, so 12 and 8, and the overall height, because 12 is going to be on there. Metric of get real loose. You put them on the model, and hopefully everybody's going to realize you're over here. Do it on the model, it shows up here. You do it here, it shows up on the model. You start double clicking on sketches and features in the assembly, you can see everything, and you can tolerance right in there. Follow suit as long as you have insert model. Redid design is what's time. We're not gonna be saving this one. But I think let's see how many. It's 7 here. We'll do one more giveaway. What I got for a second. All right. We had water and wine for the last one. This one we will have our friends over at DriveWorks. We've got coffee cup. Unscrewed it, but it's coffee here. And we have a from box. We have a hat. Thanking our sponsors for everything. Take care of us very well. Over to this side for our second one. Let's open this. That. Okay, for all one word, our keyword is going to be next week, all one word. Type that on in there. Give this guy away. Set. And give you guys your weekend. Hopefully those that are at work get Monday off for the holiday. Is it Memorial Day? Don't forget to check out the sponsors, all their all their dresses, check out whatever. Now we only got 2 there. We have Chris, Dave. So Chris has a 50-50 chance to win everything. Basic shape typing it in. it. Let's. Why is it's not in there? Try it myself, and then I win. There we go. Now everybody. Got lag in adding to. Oh, I roll it. So we got the basic shape. Chris, Tim, Dave. So what? Who are you, basic? So let's roll it. Let's see who wins. Chris, should we let somebody else win? I don't know. Nightbot loves you, but should we let somebody else win? God, yeah, hey, let's roll it again. Everything. Oh, Chris. You want me to give it to somebody else? Or do you want it all? Let's give another giveaway. I have oh, Chris will be ineligible. We'll do one more for the three of you. I got some. I love these socks. Took a pair a while ago. They're socks. I got a million pairs of the socks, but these box socks, they're so, I don't know. I love them. Wore them the first time. As soon as they're washed, I so we got the box socks from Box and shot glass from DriveWorks. Pretty cool. It's the first time I've seen the shot glass from them. So we'll do it. We'll roll it one more time. Roll it. And it is Tim this week. So Tim, you'll get the shot glass and some glass and box. Whisper me or send me an email to nCustard@expand.com and with your address out to you. I'll try to get them shipped out sometime. I'm hoping to have this again next week. We'll go more into it. We'll probably get into some sprockets and the wheels, and we'll talk about. I think we're going to do some mag wheels, deal with spokes. Which I don't design spokes. I don't think you could. I don't want it to be look stupid. Pretty cool. It's just star pattern or whatever. And I appreciate you all coming and visiting and. Hanging out with me. Tell your buddies at work about this email, and let me grow this. Get to 50 followers, which actually will let me do. And also, the more followers, and if there's a better time you think I should do. 1:30 last week, 12:30 this week, on a Friday, maybe 8 o'clock. Post something. Here, let's see, Chris. Put it in chat for those that need to send me their address. And it is just the end. All right, everybody. I'm gonna end it here. hopefully convene next week. I'm pretty sure we will. Probably on Thursday, Friday, playing with different times. Right, everybody.